Problem 13.2 Part A. You're given a balanced chemical equation and you're given some kinetic rate data. Part A asks you to calculate the rate law. So you know that rate is a rate constant. The molar concentration of the first reactant, CHCl3, to an xth power that you have to solve for, multiplied by the molar concentration of Cl2 to a yth power, which you have to solve for. First, to solve for x, let's take reactions 2 and 1. And let's divide reaction 2 by reaction 1. So we get the rate, 0.0069 molarity per second, divided by 0.0035 molarity per second, equals the rate constant, 0.020 molarity to the x, 0.010 molarity to the y, and then for reaction 1, 0.010 to the x, 0.010 to the y. So I've just taken reaction 2 information and divided it by reaction 1 information. We'll notice that this cancels to give 1, this cancels to give 2, this cancels to give 1, this cancels to give approximately 2. So what we have is 2 equals 2 to the power x. So x equals 1. Let's look at reactions 3 and 2. So we have 0.0098 molarity per second divided by 0.0069 molarity per second equals the ratio of the rate constants. Then we have 0.020 molarity to the x, 0.020 molarity to the y, divided by 0.020 molarity to the x, 0.010 molarity to the y. We'll notice that this cancels to give 2, this cancels to give 1, this cancels to give 1, this cancels to give approximately 1.4. So what we have is 1.4 equals 2 to the power y. So y is a half. So finally we can say that the rate is the rate constant, the concentration of the first reactant to the xth power, where x is 1, multiplied by Cl2 to the concentration of the yth power, where y is a half. Problem 13.2 Part B. We need to solve for the rate constant K. So we can take any of these reactions. I'm choosing to take reaction 1 and I've written it over here. So now simply solving for K, we have K is 0.0035 molarity per second divided by 0.010 molarity to the first power multiplied by 0.010 molarity to the half power. This equals 3.5, and units, the molarity here cancels molarity here, so we have a reciprocal molarity to the half, which is molarity negative a half, and then we're left with a reciprocal second negative 1.